Welcome to the Ultralight Airplane Workshop. I'm Leon. In this video, we're going to talk about a second version of a do-it-yourself sander for sanding curved surfaces. A couple of weeks ago, I made a video where I built a sander for curved surfaces. Now for that particular video and that build, I kind of just did it on the fly. I had a sheet of 12 by 12 aluminum. It was 45 thousandths thick, which was scrap, and one of the points of the video was that I could make a sander just using scraps in the shop. And I almost succeeded. I made a little mistake and made it a little bit too wide, so I couldn't use bolts and nuts that I already had in the shop. I had to go out and buy some bolts. But other than that, I used just stuff that was scrap in the shop. Now this sander works okay. It's not the best. It can do some flexing both directions, but it's a little bit stiff. And another thing, it's very similar to a design called the Flexi Sander. And I thought in the future it's possible that I'll make some kits for these sanders and sell those. So I decided I need to do something different than Flexi Sander did. So I sat down at my desk with the Fusion 360 CAD design program and I drew up another sander for curved surfaces. For this sander, again, you still use a 12-inch by 12-inch piece of metal. I decided to go with stainless steel. I intend to use this flexible sander with wet and dry sanding. Now you can do that with aluminum, but I decided I want to do stainless steel just in the hopes that it might last a little bit longer. Now this stainless steel that I got is 35 thousandths thick, just about a millimeter. And now that I've got it in my hands and I'm feeling it, it might be a little bit too flexible, but I'm going to go ahead and do the build with this. Another thing that I bought was some of this piano hinge, and that's how I'm going to make this flexible sander for curved surfaces a little bit different than the Flexi Sander. I also bought two kinds of rivets, plain old blind rivets. I intend for these to be 1/8 inch diameter, but I screwed up and got 5/32. And I have some countersunk rivets that are also stainless steel. So this build is going to be entirely out of stainless steel. The build and video I did a couple weeks ago was for my designer and builder tiers on Patreon. And I want to thank Richard and Keith for being fantastic supporters on Patreon. So they got the perk of having that build video made just for them. This week though, I'm going to do a build video for you guys on YouTube, but I'm going to make the plans available to my patrons, both the designer and builder tiers. Well, let's get to building. Let's do a quick overview of the design that'll help you kind of understand what's going on as we're making the parts and assembling them. This is a Fusion 360 here, and I've assembled the various parts here so we can take a look at it. This top part here is the handle. This is what you hold on to as you're sanding back and forth. These two are brackets here, and then this bottom part is the plate, and underneath that is where you'd put some self-adhesive sandpaper. It's at 12 inches long and 2 3/4 inches wide. Now this is designed to try to spread out the force along this bottom plate so that you have nearly an even force. So the distance between this hinge point and this hinge point is the same as the distance to this one and the distance to this one. And these hinge points are where the pressure is actually applied to the plate. And then as you can see up here, there's a hinge that's halfway between this hinge point and this hinge point. That means of the force that's applied here, half of it goes here, half of it goes here. And as long as you're pressing roughly in the middle of this handle, then that means 1/4 of the force is here, 1/4 of it here, 1/4 of it here, well, right there, and 1/4 of it here. Now keep in mind though, this bottom plate is going to be flexible. We want it to try to follow the curve of whatever we're sanding. That means that in between these hinge points, this bottom plate can flex up, or of course it could flex down on a concave surface. But when it flexes up, then this point here and this point here will have to get closer together because the overall length along this edge will still be the same. In order for it to flex up, these 2 points have to get a little closer together. In order to allow that then, we have a hinge here and we have a double hinge here. There's a hinge down here and a hinge up here. That allows this to move back and forth, which allows this to move back and forth. And then again, the same thing happens on this handle. There's a double hinge here and then a single hinge over here. And then on this side, it's just the mirrored of on this side. So only parts we have for this are the bent sheet metal. So the handle is a bent sheet metal. These two brackets are bent sheet metal. And this bottom plate is bent sheet metal. And then we have piano hinge here and here. There's two of them that's riveted together. And then this bottom hinge is riveted to the bottom plate using a countersunk rivet. And then this one is riveted here. Down here again, this one is riveted to the bottom plate. And then the other part of it, which you can't quite see here, is riveted in here. Of course, that's mirrored over here. And then we have the same thing here as we do on these brackets. So that's the overview. Let's start cutting and bending some metal and doing some riveting. Instead of having this video be an instructional video, I think instead we'll make it more of an entertainment video. And we'll just zip right through the build, doing little clips here and there. We'll have a little background music. And if there's anything that's somewhat interesting, I'll do a little text over the screen describing what's happening. Here we go. Well, I have the new flexible sanding block fully assembled, and it looks pretty good. I've done a little bit of initial testing on how flexible it is, and I'm comparing it to the first flexible sanding block that I made. This one's just a little bit stiff, but that may only be because of the tightness of the bolts through here. This one is certainly more flexible, and it doesn't rattle nearly as much as this one does. So that's a little bit of a plus. Now this one that's using stainless steel 304 alloy that's annealed. It's fairly soft and it takes a set fairly easy. So if you bend it too much in any one place, it keeps that bend, or it keeps a lot of that bend. So that's a drawback to using this. If I figure out a way to harden it, like work hardening it without permanently deforming it, I'll go ahead and do that. But it's still good enough to do some tests. And I've got this foam rudder plug that I made some time ago. And just by trying to figure out how well it'll follow this curve, I've done a little bit of a test. So laying this one down here to where this front edge is pretty much over this leading edge and pressing on it in the middle, it'll bend down just a little bit, not much. But now I do this one, put it in the same spot, bend it down, it bends down far more. Now, I think that's only because, as you can tell if I put these on top of each other, the pivot point for this front edge of the old aluminum one is back from the leading edge about 1.5 inches. But on the other one, I put it up within about 3/4 of an inch of the leading edge. So that helps a lot in making it bend. And that's probably the bulk of why it does that. Another thing is it's a little bit thinner than the aluminum, so that helps also. Now, the other thing is it's way heavier than the aluminum, but that's not really an issue. So I want to do a little experimenting with it. Let's do some sanding with it. I have some 80 grit adhesive back sandpaper that I'm going to put on it, and we're going to do a little sanding on this rudder plug. Well, the new flexible sanding block does a really good job of sanding down these fairly smooth surfaces that have a little bit of curve to it. I think it did a really good job of that. Now this is still a little bit too stiff to be good on foam. I think I want to do is make another one that's using a little bit thinner metal, and hopefully I can find a metal that's a little bit easier to harden for the plate. I don't mind if I have soft metal up here for the bracket and handle. I like to have a little bit springier, not as soft metal for this bottom plate. So I'll have to work on that a little bit. And a little bit thinner. I like to be just a little bit more flexible. This was around 35 thousandths thick if I remember right. I like to go down to around 27, 28 if I can. 25 thousandths thick also might be worth a try. Now this would probably be about right on fiberglass. When you're trying to fare fiberglass, when you're using something that's a little bit more robust than foam is, this is probably just about right for that. For the most part, I'm liking this design. And this is just an experiment with playing with stainless steel. I think it would be perfectly reasonable to make one of these out of aluminum. Well, for my builder and designer tiers on Patreon, I'm going to make the plans for this available. So if you're one of those guys, feel free to try to build one of these from that and experiment and make slight differences on it. Or just use this design as an inspiration and make something all on your own. Don't forget we have a Facebook page. There's a link to that down in the description for this video, where I put short clips and photos of things that I'm working on as I'm working on them. And so you can kind of see that things are going on even when I don't have a video out for a little while like I did for this one. There's quite a bit of time between the last release and the release of this one. But there are some more videos. I have another one in the works on a heating box controller, and I'm getting ready to work on the test mechanism for doing shear tests. So stay tuned.